Okay, geometry, welcome to day 2 of section 2-6, geometric proofs. And yesterday you were doing a fantastic job of giving the reasoning, the justification for the steps that were given in 2-column proofs, right? We took it step by step and we took it easy, so be sure that you're taking it slowly as you're doing these first proofs. It will really pay off for you, right? So this geometric proof that we're going to work on today are the actual 2-column statements and reasoning. So remember, we begin with a given. In geometric proofs, you're given something, and then you're asked to prove something, which gives us the hypothesis and conclusion. We're giving all the statements and reasoning in between, right, as we show the step-by-step in our 2-column proof. So recall yesterday, in the left column, we have our actual steps of the proof, right? And you were completing the right column yesterday, which shows the reasoning or the justification, right? All right, so here again is a 2-column proof, a simple 3-step one, and we're just going to look again at the reasoning. So given segment XY, prove that segment XY is congruent to segment XY. So it sounds basic, making it maybe more challenging, right? So segment XY, we can see, is given. We always begin our proof with the given statement, so that makes the first step quite easy, right? Sometimes we'll have a bunch of given things and we will spread that out in our step-by-step statement, our proof. But in this case, we put it right there in the first line. We now can say XY equals XY. Why can we say that? Well, we were given a segment, just a single segment, right? And what did we call this? We were looking at various reasonings 2 days ago, right? Various logic steps, and this is the reflexive property of equality, all right? So if XY equals XY, we now can state what we were setting out to prove, and that is that XY is congruent to XY. And that is based on this step, right? The previous step tells us that XY equals XY, so this is our definition of congruent segments, all right? Very good. So we're using a property and a definition in our reasoning. So here we have, again, a 2-column proof. We are given the steps. We're just going to fill in the blanks. We're working our way toward doing this entire 2-column proof on our own. So read this and think. Our first step then will be the given information, right? Angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, okay? Notice what they do in the second step. They use what we placed as our first statement, and they tell us that the measure of these supplementary angles equal 180. And so this is the definition of supplementary angles, right? So what can we say in the third step? Well, if both of these expressions equal 180, we can set both of these expressions equal to one another, right? So there you go, and that's our substitution, which we experienced that in one of your assignment problems yesterday. All right, so now we're going to say the measure of angle 2 equals the measure of angle 2. This is a reflexive property of equality. We just saw that in the previous proof, right? And why are we saying that? We're saying that because we're going to use step 3. Look at that, these two are equal. And because the entire expression are equal, we're now going to say angle 1 and angle 3, those measures are equal. And why can we say that? The subtraction property of equality. So we have subtracted angle 2, that measurement from both sides of the previous, or step 3. All right? Good. And now finally, the last step, as I said, will always be the statement we were setting out to prove. So angle 1 is congruent to angle 3. That is because in step 5, we say those two angles are equal, right? And so angles that are equal, we say define congruent angles. So there's your definition. Very good. All right, let's try it again. Oh, here's a hint. One thing you can do is plan your logic statements straight out and then write your proof. You can either do them as you go, or you can write the statements first and then your reasoning second. Here are two theorems that you might need to use in proving these statements today. The first is all right angles are congruent. So if angle A and angle B are right angles, they are congruent. So we would call this the right angle congruence theorem. Second, if two angles are complementary to the same angle, then the two angles are congruent. So if angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, angle 1 and angle 3 are complementary, right? So this is like our supplementary, our congruent supplements theorem. It's just the congruent complements theorem. Very exactly the same, isn't it? Except we're talking about complementary angles now. So sometimes we need to draw a picture or draw in the given information. It's really helpful to use the pictures that are sometimes given. If not given, draw it so you can see what it is you're working with. Remember, do not draw in what you're asked to prove as though it exists in the statement. You need to keep that kind of the unknown. We're trying to get there, right? So let's go ahead and write a 2-column proof. Pause, read this, and come on back. You know, the nice thing here is that they give you a plan with a lot of the reasoning that you might use in writing this 2-column proof, right? So, as we said before, the very first line of our proof is probably all of the given information here, or at least some of it, right? And actually, in this answer, we have all of that given information. So that's just given, right? Then remember, the final step will be what we have set out to prove. Angle 3 and angle 2 are complementary, and we have a 5-step proof here, okay? So if angle 1 and angle 2 are supplementary, then what can we say about angle 1 and angle 2? Those measures equal 180, right? Good. And that is because we know they are supplementary. That's just our definition, right, of supplementary angles. Next step. We know that angle 1 and angle 3 are congruent, so what can we say there? We can say that they are equal, right? So again, we're just using the given information to establish what we have here, and that is they are equal because they are congruent, so that goes to our definition of congruent angles. Okay, if that's true, let's look at steps 2 and 3. How can we kind of combine what we have here? If angle 1 equals the measure of angle 3, we could probably substitute, right, angle 3 into the position that angle 1 was in, right? And say that measure of angle 3 and the measure of angle 2 is 180. So we've just taken measure of angle 3 and plugged it in, substitution. All right. And finally, what were we setting out to say? Angle 3 and angle 2 are supplementary. And look at that, we have the measures summing to 180. So we can now say angle 3 and angle 2 are 180, or I'm sorry, are supplementary based on the fact that supplementary angles sums are 180. So that's the definition of supplementary angles. All right. Okay, let's try it again. Pause the video and see what you can come up with. Well, this feels a bit like the last one. We're being asked a slightly different question. Over here, we were being asked to find that 2 angles were supplementary. Over here, we're being asked to find that 2 angles are congruent. But kind of a similar question, isn't it? So, and they actually provide a picture and some planning for you. So, first step, I'm sure you have the given information, right? There it is. Okay, so once you have the given information, we use that to say something in the next step, right? So, because angle 1 and angle 2 are complementary, what can we say? The measure of angle 1 plus the measure of angle 2 equals what? 90 degrees, right? Same is true for the measure of angle 2 plus the measure of angle 3. And why can we say that? Because that's the definition of complementary angles. Good. Okay, so now that we've said that, this is interesting. Do we see anything in step 2 that we could use? Well, they both equal, these expressions both equal 90, right? So I guess we could set them equal. So we could say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what is our reasoning here? Well, we just substituted, didn't we? Okay, next step. Well, looking at step 3, I see angle 2 appearing in both sides of this equation, right? So we might want to state the fact that angle 2, that measurement equals the measure of angle 2, as we've seen before, right? And once again, do you remember that property? I bet you do. Reflexive, right? Reflexive property of equality. So let's look again at step 3. Because these two angles are the same, could we simplify this expression? Yep, we can subtract measure of angle 2 from both sides, can't we? And so we call that the subtraction property of equality. Good. And whoops, I'm moving the wrong thing here. Let's see, go back up. All right, what were we setting out to prove again? Angle 1 is congruent to angle 3. And look at that, we're ready to say that here. Based on step 5, these two angles are equal in measure. We're going to now say that they're congruent angles. And that's because we know that step 5 shows us the definition of congruent angles. Ta-da! Good. All right, you have one lesson quiz proof, and then we have an assignment. All right, so pause, try to write a 2-column proof for this, and then come on back, check your work, and go on to your assignment today. Okay, you're back. I'm going to quickly reveal the answer, and you can pause the video and check out this reasoning since it's the lesson quiz. I won't walk through it. You can check it out. Pause the video. And there's your assignment. Remember, take your time to be very, very, very specific, very careful. Check your work very carefully. It will really pay off for you this year. Good job.